Math 3, Unit 9, Section 4. Today we're going to be talking about scale factors of similar figures. Okay, if you notice in this chart below, we are going to be looking at the ratio between figure 1 and figure 2. Okay, so I would like us to go and we're going to look at both of these figures. You will notice that they are both rectangular prisms, correct? Okay, so if we look here, we're going to be talking about the height of each of them, the perimeter, area, surface area, and volume. Okay? So, starting here at the heights. Do you guys see heights? What do you think the heights are? So our heights are the 12 and 4. Is everybody okay with that? Yes? So if we write this as a ratio, we have 12 to 4. But when you're dealing with ratios, you're always going to end up reducing them. And so can I reduce them? 3 to 1 is correct. Manveer, did you have a question? So on figure 1, the height is 12. I can't find my highlighter. And on figure 2, the height is 4. I'm going to... So here's figure 1, here's figure 2, here is this height, here is this height. Okay, we good? All right, perimeter. So we are just going to take the perimeter of the base. So when we're doing a perimeter, it is just, first of all, height. Is this one-dimensional or two-dimensional? It's one-dimensional, okay? So I'm just going to put one-dimensional here because this is going to be helpful as we see patterns. Perimeter, is it one-dimensional or two-dimensional? One-dimensional. Good. We'll just kind of go through this list here real quick. Area, 1 or 2? Area is two-dimensional. What about surface area? Two-dimensional. And then what about volume? Very good, three-dimensional. Okay, so on figure 1, my perimeter, okay, so we are just doing the perimeter of this figure. So that means, what numbers would I add for the perimeter? 15 plus 9 plus 15 plus 9. Okay, because if there's a 15 here, there's a 15 in the back, right? Even though we can't see it. And if there's a 9 here, there's a 9 over here. So yes, because it's one-dimensional. It's like your flat dimension, okay? So we're doing the base is where our perimeter is. Yeah, so we're going to add all those up and we get 48. Go ahead and find the perimeter on figure 2 on your own, and then I want you to write the ratios and reduce them. If they, help yourself. If they score 85% or better, I bring in treats as a class project. No, she bribes us to get the treats. That's what we all do. I bribe my kids to brush their teeth. Yeah. Have some candy, but brush their teeth. Yeah, exactly. Have this first. No, just pop it in. Okay. Yeah, this is your it's only March. Okay, so can somebody share what they got for the perimeter on figure 2? 16. Good, 16. So again, we're adding 5 and 3 and 5 and 3, which is 16. So when we write that as our ratio, it is 48 to 16. And can those reduce? By what? So if you do by 4, what did you end up getting? Oh. Did somebody say 16? Okay, 16 is actually correct, but 4 would work, but then you should see that you should reduce more. Did some of you divide by 4 and then realize, oh, I can divide by 4 again? Yes? Okay, good. So what did you end up with the ratio? Okay, so let's get our calculators out. 48 divided by 16 is 3. And 16 divided by 16 is 1. Okay. I want you to watch this and see what happens if we notice patterns. Do you notice something between the height and the perimeter? The ratio are the same. They are both one dimension, And they both end up having a ratio of 3 to 1. Okay, so next we're going to move on to the area. Okay. So area. How do I find the area of this figure? Again, area is two-dimensional. So remember how we are finding the area of the base? That's what we're doing right now. We're going to find the area of the base. Exactly. 15 times 9. And so if you have a calculator, multiply 15 times 9, what do we get? Perfect. 135. Okay, so the area of this one is going to be 5 times 3, which is 15. So we're going to find our ratio again. So we have 135 to 15. Very good. We reduce that, and we get 9 to 1. And when you're reducing, if you notice that you can divide by 5, and then hopefully you'll notice that you can divide by 3. Or if you're like, I know I can divide by 15, because look, in this area has a 15, and in this area, 5 times 3 is 15. So maybe you notice that for reducing. Okay, so one-dimensional was 3 to 1, and two-dimensional was 9 to 1. Okay, does anybody have a guess what this one's going to end up reducing to be? You guys are smart. Okay, I'm pretty sure you're right, but let's go ahead and figure it out. No, we don't want to figure it out? Okay, surface area. Okay, so how do I find surface area? Do you guys remember surface area? So it's area of all of the different sides, right? And so we've already done the area of the base, but there's two of those, right? Because you have your bottom area and the top. So that means we would have, for surface area, 2 times 15 times 9, plus we have the sides, right? What? Okay. Is that enough? No? Okay, so we have another side right here, and this one is 9 by 12. So there's a side here and a side over here. Do you guys agree? So we're going to go 2 times 9 times 12 plus, and then I have my front. And what is my front and back going to be? 2 times 15 times 12. What? Okay, so we're good now? Do you remember? Okay. So.
And that has to do with sides, right?
Yes, it has to do with sides. There's 6 sides. So this, like if we take a Kleenex box here. So to start here, we had, this was like the 15 by 9, like 15 and 9. Okay? So there's 2 of these. So that's why I'm taking the area of this and the area of this. So instead of doing 15 times 9 plus 15 times 9, I know there's 2 that are exactly the same. 2 times 15 times 9 to take care of these. Okay? And then I did 2 times 9 times 12 to take care of these sides. And then I did 2 times 15 times 12 to take care of these sides. So in a rectangular prism, there are 6 sides. So 2, 2, and 2 that took care of all my sides and the area of each of the sides. Okay. You're welcome. Okay, so we multiply 2 times 15 times 9, and it's 270. Plus 2 times 9 times 12 is 216. And 2 times 15 times 12 is 360. And you add all those together, and we get 846. Very good. Okay, so now we're going to do the surface area of figure 2. I'm going to move this up. Are we good? Okay, so surface area. We have 2 of our bases. So 2 times 5 times 3. Okay, what's another side that I'm going to do? 2 times 3 times 4. Good. And then my last one is 2 times Yes, 2 times 4 times 5, sorry. Okay, so we multiply those out. 2 times 5 times 3 is 30. 2 times 3 times 4 is 24. And 2 times 4 times 5 is 40. And we add all those up and we get 94 is correct. Okay, so going to our figure 1 to figure 2, we have 846 to 94. And it does reduce to 9 to 1. What did you divide by to get it? Or did you just know it?
I just knew because there's a pattern of one dimension is 3 to 1 and 2 dimensions is you just square it and then.
So what do we think we're going to do for 3 dimensions?
It's going to cube it.
It's going to cube it. So what do you think these answers are going to be?
27 to 1.
27 to 1 is correct. Okay. So, volume, just because I want us to kind of fill in part of this, and then maybe since you guys caught on to this, we will do less work on the next one. But, so volume of our larger figure, we would multiply all these sides together. Okay? So, 15, because our base area, 15 times 9, times our height, which is 12. We multiply all of that together, and you get 1,620. Figure 2, what will I multiply? Good. 5 times 3 times 4. We multiply all that together and we get 60. Very good. So on this one, we have 1,620 to 60. And so you would reduce, so we know based on like what we've done here is that like 846 was actually divisible by 94. If you want to check that in your calculator. Based on what we think it is, 1,620 is divisible by 60. And if you check that in your calculator, it works out. Okay. What is interesting is that this will always be the case if you have similar figures. Okay, they will always have the same ratio. And so if you have similar figures, you can figure out a lot of information based on their ratios.
There is always a ratio.
So similar figures, if they tell you that 2 figures are similar, okay, they will have similar ratios, okay? So let's go ahead and start on this one again. What would be the perimeter of this figure? And with circles, the perimeter is actually the what? Their circumference. So how would I find the circumference of this? 2 pi r is circumference. And so in this case, 2 pi times, what's my radius? 6. So it will be 12 pi. Okay? On figure 4, for my perimeter, which is actually the circumference, is 2 pi times what? 4, which makes 8 pi. Okay, so when we write our ratios, we had 12 pi and 8 pi. So figure 3 to 4, 12 pi to 8 pi. Now if we reduce, do you guys notice how the pi's will cancel out?
Yeah.
And then we can also reduce by what number?
4.
Good. And so we end up with
3 to 2 ratio.
3 to 2 ratio. Okay? Which means, oh, that was not, I just realized, I just did perimeter, huh?
Yeah.
The height, if you notice, is also what? 3 to 2. Okay. So you can write that in the correct one. Okay, so based on what we know, what do you think the area, what do we think? 9 to 4. We are squaring them. 3 squared is 9. 2 squared is 4. Okay, surface area. What would those ratios be? 9 to 4. And Lavina, you cannot answer anymore. Volume. What will volume be? What is it? 27 to 8 is correct. So what am I cubing and squaring? Which one? So whatever your one dimension is, we're squaring to get the 2 dimensions, and we're taking that value and we're cubing it to get the 3rd dimension. Okay, so figure 5 to 6. What do we think is going to happen with figure 5 and 6? What are our heights for those? 20 and 8. Okay, so I'm going to leave you alone. I'm going to walk around and check your work. I want you to try to figure out the ratios, each of the ratios in the chart for figures 5 and 6. If somebody thinks they have all of them, raise your hands and I'll check them. Don't forget that when you're doing the ratios, you always need to reduce them as much as you can prior to doing anything else. Okay, do I have a volunteer, somebody that wants to come up and explain things for me? You didn't do it wrong, you did it right. Okay, come on up. All right, so Lavina's going to come up and explain figures 5 to 6 to us. If you already understand it and have it down, read the questions to the right as she's kind of going through it to see if you can figure those out.
Okay, so figure 5 to 6 is a 20 to 8 ratio, which reduces to a 5 to 2 ratio.
Okay, so what did we reduce by? What did she divide both the numbers by? 4. Okay, so now we have our 1 dimension value. Okay?
Knowing our 1 dimension value, we can fill in our other 1 dimension value. And then our 2 dimension value will be 25 to 4. 25 to 4 again, and then our 3-dimensional will be 125 to 8.
Perfect. Okay, but this will only work if they tell you the figures are similar. Okay? All right, so let's look at these questions right here. It says use the table, describe the scale factors. What is the relationship between 1-dimensional and 2-dimensional values? So, yeah, so if I did these, one of them is a single value, where the other one is a squared value. Okay, and so you could even write it like this, single to squared. Okay, what's the relationship between 1-dimensional and 3-dimensional? So that would be a to a cubed, right? 3 dimensions are cubed, okay? Or again, like a single value, a single number to the cubed. Okay, and what is the relationship between 2-dimensional and 3-dimensional? That would be a squared to a cubed, or squared to cubed. Do we have any questions before moving on? Yes. So the 125 came from taking your single dimension or your 1 dimension and cubing it. So 5 to the 3rd power is 125. Any other questions? Okay, so we're going to move on to this next page, and in fact on your test you're going to be given a similar chart to this where they want you to fill it in. Okay, it's important to understand the difference between 1, 2, and 3 dimensions. Okay, so I always like to start by writing what each of the dimensions are here on the side, because it helps me fill in my chart later and I don't have to think about it every single time. And so we know that height is what? 1 dimension. Okay, so if you want to put 1, you want to put 1D for 1 dimension. Maybe that's better. I don't know. Whatever makes sense to you. Perimeter is what? One dimension, okay? Area is 2. Surface area is 2, and volume is 3. Okay, so I'm just going to give you about 10 seconds, maybe 15. Fill in this chart. I'm not going to have time to walk around. Not, just fill in the first column, sorry. So, if the first one is 1 to 2, the perimeter of the next one is going to be what? It's going to have a 1 to 2 ratio. What about the area? 1 to 4. Surface area? 1 to 4. And volume is going to be 1 to 8. Did you have a question? Okay. Now, figure 2. This time they give us this 3 to 4, which is what dimension? 1 dimension. And so going backwards, the height is going to be what ratio? 3 to 4. What will be the area of the base? 9 to 16. So this one didn't have 1s in it, but you just still have to square your first ratio and square your second one. Surface area will be what? 9 to 16. And then volume will give you what? Perfect. Okay. On the next column, they are giving us a 2-dimensional ratio. What would I need to do to this in order to get back to 1-dimensional? Square root it. So what is the square root of 4? 2. What is the square root of 49? 7. So my perimeter is 2 to 7. What would be my height? Okay, what would be the surface area? Very good. And what would be the volume? Very good. Okay, on this last one, they're giving us a 3-dimensional ratio. And so what would I need to do to this? Take the cubed root. Good. So going backwards, I want to go back to my 1 dimension. What is the cubed root of 1? And what's the cubed root of 27? 3. And so perimeter will be 1 to 3. Area of the base is going to be very good. And surface area. Okay. All of this is important for the problems that we're going to end up doing. Okay. So we are going to be working with similar figures here. And so this first problem, it says the 2 boxes below or to the right are similar and both have to be wrapped with decorative paper. You know what? This is actually the hardest one. We're going to skip 1 for a minute. We're going to go to 2. Sorry. We're going to start easier. I have to make this a slight bit smaller. And still smaller. Okay, here we go. Number 2. The figure to the right is of 2 shampoo bottles that are mathematically similar. And the cost of the shampoo depends only on the volume of liquid in the bottle. Okay, so first of all, notice they are talking about volume. Do you guys agree with that? Okay, so I normally will end up putting here that this is going to end up being a volume problem. We know that volume is what dimension? This volume is a 3-dimension, okay, which is important to know for when we're doing our ratios, okay? It tells us the small one costs $4. What should the large one cost? So we know this one costs $4, and we are going to try to figure out the cost of the bigger one. Now, they've given us 2 pieces of information right now. What have they given us here? The heights. Height are what? 1 dimension. So when I'm going to start here to figure out my ratio, I am finding the ratio in 1 dimension right now. Okay? And so right now my ratio is 18 to 27. And what does that reduce to? 2 to 3. Okay, if you have 3 to 2, it doesn't matter. It's just which one's bigger or smaller. Okay, so the ratio is 2 to 3, but for this problem and finding the cost, the ratio is based on volume. So since I'm dealing with volume, what do I need to do to this ratio? Cube it. So for this problem, I need to cube 2, which will end up giving me an 8, and I need to cube 3, which is going to give me a... So this is the ratio I'm going to use for volume. Okay? Now, in order to find the cost, all we're going to do is set up a proportion. Okay? So what do I mean by that? We're going to write this as 8 over 27 equals, now $4 needs to match with which one? 8 or 47? 8. So it's going to be 4 over x. So you always want to match up. If they'd given me the larger amount of dollars for the bigger one, then I would have put that on the bottom. Okay? So 8 is smaller, which matches with the dollar amount for the smaller one. And then all we're going to do is cross multiply, and we get 8x equals, and 27 times 4 is 108, and we divide by 8 to both sides, and I get the answer of what? $13.50, and that is my answer. Okay, does anybody want to ask me questions? You're not sure where a number came from? Okay, number 3, let's try it. Okay, the cylinders to the right are similar. The volume of the smaller cylinder is 12 cups. So this volume right here is 12 cups. Okay? Find the volume of the larger cylinder. Okay, again, this one they are telling me to find the volume. Volume is dealing with 3 dimensions. Okay? But in terms of similarity right now, they've given me my what? My height. And so my ratio right now is in which dimension? It's in 1 dimension. So I have 5 to 25 right now, and that reduces to what? 1 to 5. Good, because we can reduce that by 5. So what dimension, what will I need to do to that in order to use the ratio for a problem where I'm using volume? Cube them. Very good. So I cube 1 and I get 1, and I cube 5 and I get, okay, yes? So now we're going to set up our proportion. I'm going to give you just about 10 seconds to write your proportion on your own. Okay, who can give me the ratio? Or not the ratio, the proportion. Who can give me the proportion? Anybody besides Lavina? Nia, thank you. Perfect. Okay. Does anybody have questions about the proportion? Okay, cross multiply. 1 times x is x. 125 times 12 is? And so guess what my answer is? 1,500 cups. Yeah, pretty big. Okay. Any questions there? All right. We're going to go to number 4. The surface area of 2, first of all, they just said surface area, okay? What dimension is surface area? Okay. The surface area of 2 similar solids are 3 inches squared and 75 inches squared. Okay. So I'm just going to write this right now. So I know surface area is 2 dimensions, and they told me 3 to 75. Okay, should we go ahead and reduce that? Okay, what does it reduce to? This reduces 1 to 25, but if I want to go to 1 dimension, what would the 1 dimension be? Because this is 2 dimension, right? All the other ones, they gave me information on 1 dimension, but this one gave me surface area, which is actually 2 dimension. And so if I want to get to the 1 dimension, what do I have to do? 1 to 5. Okay. So now it says if the larger solid, so this one they're telling us the larger one, has a volume of 875 inches cubed, what is the volume of the smaller solid? Okay, so what ratio will I use in order to solve this? What will I need to do to the 1 to 5? Cube it, because I'm dealing with volume. Okay, so when I cube these, what do I get? Very good. 1 and 125. Okay, I'm going to give you another 10 seconds to set up your proportion. Okay, can somebody that hasn't shared anything with me tell me what it is? Sochi.
1/125 equals x over 380.
Perfect. Why did she put x on top this time and 875 on the bottom? Gave me the volume of the larger one, so I need those to match up. Okay? So we cross multiply, and I have 125x, and 1 times 875 is 875. Next, I do what? Divide by 125 to both sides, and I get x equals 7 inches cubed is the volume of the surface area of the smaller one. Okay, we're going to go back to the first one, which was a little bit more complicated. Okay, so the two boxes below are similar, and both have to be wrapped with decorative paper. If you're wrapping something, what are we dealing with? Surface area, okay? So we're end up going to be dealing with surface area. If it requires 4 yards of paper to cover the large box, so this large one is 4 yards, okay? Calculate the amount of paper needed to cover the smaller box. Okay, and surface area we know is 2 dimensions, okay? Now, before I get into all these different measurements, because we have 4 yards versus inches, so we're going to have to do some conversions here. What should I do with my ratio? Let's set it up first. So my ratio is 18 to 15. And what dimension is that ratio in right now? It's in height, which is 1 dimension, right? Okay, so we reduce this, and what does it reduce to be?
6 to 5.
Okay, 6 to 5. Okay, but for my proportion, we're dealing with surface area, and so what am I going to end up using? Squared, which is going to be 36 to 25. Good. And so one side of my proportion is 36 over 25 equals, and now we have to figure out what to do with this information, because we have yards and inches, and we need to change them. Does anybody know how many yards are in an inch? I mean, how many inches are in a yard? Very good. 1 yard equals 36 inches. Okay.
So you have to use 36 times 4 to get the amount of inches that you need for 4 yards.
Close. Because we're dealing, and I forgot to put this, we're dealing with yards squared. We actually are going to take, for yards squared, we have to go 36 times 36, which is 1,296. And since there's 4 of them, it's 4 times 1,296, which equals 5,184 inches squared. Now, I have good news. On your test, it's not going to be in yards. They're going to leave everything in inches. So we're getting a more complicated one in our notes than you're going to get later on, okay? But it's still good to understand how to do these conversions, okay? So here we go. So this is, where is this value going to go?
On the top. On the top.
Top. Why is it going on the top?
It goes with the bigger.
It goes with the bigger one. 5,184 is going to go on the top. X goes on the bottom. We are going to cross multiply. 36x equals 129,600. We divide by 36 to both sides. And we get x equals 3,600 inches squared.
You have to calculate it.
And if we want to change this to yards, you would divide by our yards squared, because we're dealing with inches squared. So you would divide that by 1,296, and it ends up giving you approximately 2.78 or 2.8 yards squared. Okay. Any questions?